Hi everyone, here is a 2D rig that simulates a 3D head turn in Blender Grease Pencil. In the last video, we saw how to construct the basic objects required for the rig, from sketch to a fully rendered Grease Pencil drawing. In this video, we will see how to apply a simple Grease Pencil rig to our model. We will be using an armature, lattices, and basic constraints. This rigging will help save time when animating our Grease Pencil objects and will prepare us for the next stage, in which we will create the head turn actions. This tutorial does rely on some basic to intermediate knowledge of Blender. So, once again, I have added links to some excellent tutorials for beginners in the description. I'm relatively new to Blender, and I'm new to making tutorials, so if I'm moving too fast, using unfamiliar keyboard shortcuts, or doing things that are just a bit unclear, please feel free to ask for help in the comments section, and I'll do my best to respond. I've also linked to the final blend file so you can try it out for yourself. This video is one of 4, detailing the character's creation from sketch to model to rig and finally covering my animation workflow. Okay, let's begin. First, we're going to add a lattice for each of the objects that will need to deform in the final rig. These include the main head, nose, eyebrows, frown or glabella lines, and the hair at the top. For each lattice, it's important to encompass the entire object that it affects. Also, it's important to give it adequate resolution. For organization's sake, we should remember to keep our lattices in their own separate collection. Once we've added all of the necessary lattices, we can add a lattice modifier to each object and attach the appropriate lattice. For the head, we only want the outside to move with the lattice. To do this, we will add a vertex group that includes the vertices from the base color and the lines around the outside. This means that the mouth and other facial details won't be affected. Now that that's done, we can add an armature. Press Shift A and select armature. Selecting that, under the viewport display, we check the In Front box. This means we can always see the armature despite what's in front of it. Also, I chose to change the Display As option to Stick. The bones will be displayed as lines. First, in edit mode, we add a root bone. This is a bone that won't be animated, but is used for the initial position and scale of a character in a given scene. Even though this character is simply a head, I still want this bone, and once again, make sure to name everything correctly. Then, we add a base bone for our head. This is parented to our root bone. With regards to naming conventions, all of the bones that directly affect the grease pencil objects, we add the prefix DEF. This indicates that these are deformation bones. The other prefixes that we will use include MCH for mechanics and CTRL for control. We will also separate these onto their own layers. On the first layer, we add the bones for all of the moving parts of our rig: the hair, the ears, the eyebrows, with 2 bones for each, and 4 for the glabella lines. For the hair at the top, we add 2 bones, one that controls its overall position, and one that will bend the top. This will help with the head turn later. Then we mirror the bones from one side to the other by pressing Ctrl M, then X to apply it along the X-axis. We then rename the new bones based on their new position. There are other ways for this to be done automatically, however, here we've done it manually. You might notice that I've added screencast keys. Hopefully this will help clarify my actions when I'm using keyboard shortcuts. For each of the lattices, we add an armature modifier. Select the armature, and then create vertex groups. These groups must be named with the exact same name of the corresponding bone, or else it won't work. In edit mode, assign all the vertices to their corresponding group. Here we've done this for the eyebrows, and now the bones control the lattice and therefore the object. You can see that this bend is quite sharp. To smooth this, we select the lattice and we set the interpolation to linear on all 3 axes. Then back to the armature, we select all 4 eyebrow bones. Then, under the Bone Properties tab, under the Bendy Bone Settings, Alt-click on the Segments value and set it appropriately. Here, I set it to 16. Now we can see that the eyebrows can bend more smoothly. We repeat the steps for the other eyebrow. You can see here that I failed to assign the vertices and had to go back and assign them. We also set all the segment values for the glabella line bones to 16 as well. Remember to Alt-click if you want the value to apply to all of the selected bones. Add the modifier, add the vertex groups, assign the vertices, and repeat these steps for all of the lattices. So there you go, they all move smoothly. Now we're adding another bone off to the side. That will control all of the other facial features, like the cheeks and the mouth. Then we add an armature modifier to the head grease pencil object, as opposed to the lattices. Then add the vertex groups to this new bone and assign all of the vertices of the facial features. Essentially, everything you didn't assign to the lattice modifier. I chose to assign the mouth vertices to another bone that was a child to this new bone. This was less helpful than I thought it might be, so you could just as easily assign it to this existing bone. Make sure to parent this correctly. In this case, the mouth bone is parented to the face bone, which is subsequently parented to the head bone. Here we add some eye bones, I.L and I.R. We mirror one eye bone to the other side by selecting it and pressing F3 and searching for Symmetrize. This is another way to mirror bones, and in doing so it automatically renames them correctly, as long as you use the naming conventions .L and .R. Now to assign the hair and ears, which don't have lattices, to their respective bones. We are going to add armature modifiers directly to the grease pencil objects. Then we create correctly named vertex groups and assign the vertices to them. You can see the hair is now parented to the bones, and we can do the same for the ears. Now we're going to add two nose bones and assign the nose lattice to them using the armature modifiers and vertex groups. Because the bones overlap the head bone, we can select the head bone and press H to temporarily hide it. Make sure you parent the nose bone to the head bone, Ctrl P, before doing this. I forgot to do it here and end up doing it later on. Once again, the bones are turning quite sharply, so we will use the bendy bone segments again to smooth this out. Here we unhide the head bone, Alt-H, and parent the nose to it. We do the same to the eye bones and make sure that the grease pencil objects are attached to them correctly. Armature modifier, vertex group, and assign the vertices. Here we add the lattice to the hair on the top, but unlike the others, we assign the vertices to the groups differently. Under the vertex group panel, there is a strength slider. By default, this is set to 1. For the first hair bone, we assign the bottom 2 rows of vertices with a strength of 1. Then, the next row up, we use a strength of 0.5. Then the second highest row with a strength of 0.25. And finally, we leave the top with a strength of 0, or simply don't assign it. For the other bone, the bone for bending the hair, we do this in the reverse order. When assigning the top row, we set the strength to 1, the next row down to 0.5, with the next row at 0.25, with the remaining rows set to 0 or unassigned. Now you can see when the top bone is moved left and right, it curves the hair to give the illusion of it following the contours of the head. We now have completed all of the deformation bones. We test them and make sure they are parented correctly and deform their objects correctly. Now we will move to another type of bone, the mechanism bone. These bones don't affect the objects directly, and you as the animator will not directly control them. Instead, you will use the control bones to affect the others. We will start with the glabellar lines. At the beginning and end of each glabellar line bone, we will extrude another bone above it by pressing E. We name these bones correctly with the prefix MCH. These bones will be moved to another layer. We do this by selecting the bones we want to move and pressing M, and then select the next available box in the menu that pops up. We then parent the far left deformation bone to the far left mechanics bone. Now we go into pose mode and select the next MCH bone and shift select the far left deformation bone. Then pressing Ctrl-Shift-C will bring up a list of bone constraints. We select Stretch to. With this, the deformation bone will always stretch to the mechanics bone. Make sure all of the mechanism bones are parented to the base head bone so it's not left behind when moving the head. We repeat this for all the remaining bones along this chain. Before we can play with the mechanism, it's important to select each deformation bone in the chain and under the Constraint tab, set the volume setting to Z. This means that when the deformation bones scale, the glabellar lines won't stretch vertically. Now, by simply controlling the mechanics bones, the glabellar line curve is intuitively controlled. As an animator, we don't want to have to do this all the time. To avoid this, we will use the position of the eyebrow control bones to control these bones for us. So now, we will create a similar system for the eyebrows by extruding up all the eyebrow points into new bones by pressing E, renaming them with the prefix CTRL. Then moving them to a new layer by pressing M as we did previously. Parent the root bone of each eyebrow to the appropriate control bone, far left for the left and far right for the right. We then add the Stretch to constraint using Ctrl-Shift-C as before. Then, as we did before, select each deformation bone in the chain and under the Constraint tab, set the volume setting to Z. This was done using the same process as we used for the glabellar line mechanism bones. The final step for our eyebrows is to enter edit mode, and by pressing G and Y to move along the Y-axis. Shift all of the control and deformation bones forward to be roughly level with the eyebrow objects. Now, we will add some bone constraints to allow our eyebrow control bones to control our glabellar line mechanism bones. For the far right mechanics bone, add a copy location constraint under the constraints panel that targets the far right eyebrow control bone. Set the constraint to use local space to local space. Here I use local with parent, which causes issues later, so stick with local space to local space. As we make our way across the glabellar line mechanics bones, we use the same process. However, for the next bone, it is placed in between two control bones. So, We add 2 copy location constraints, each targeting the control bones, one for each side, the influence of both being set to 0.5. We continue across using the same principle. So now we can intuitively control the glabellar lines by simply moving the eyebrows. For each of the constraints, we uncheck the X and Z checkboxes so that the glabellar lines only move vertically. In regards to the glabellar lines, as you can see, I ran into some problems. I fixed this first by changing the constraints to use local space, as I mentioned. Also, to add functionality for the next video, I duplicated all of the mechanism bones and moved them up. The bottom row parented to these new bones. The bottom row has the copy location constraints and are therefore controlled by the eyebrows, while I'll use the top row in the next video for the head turn. If you're finding the glabellar line rig hard to follow, you can of course leave it out. I decided to keep it here as it's a good demonstration of the mechanism bones, and it also could be helpful for future rigs. To prepare our rig for our head turn actions, we now add 3 mechanics bones off to the side. These will control the eyes during the head turn. We need to make sure that we parent the middle of these 3 to the head bone so they follow the head. We also parent the left eye deformation bone to the left of these new bones, and parent the right eye deformation bone to the right of these new bones. Finally, we parent both bones to the center of these 3. Now we will create the controls for animating the eyes. For each control, we need to make 2 bones, one to move the control itself, and the other will control the eye movement. For the eyes, we make 3 sets because we want to be able to control each eye individually, as well as the ability to control both eyes simultaneously. For each, we make sure that the control bone is parented to its base bone. We then add copy location constraints to each of the left and right control bones, making sure that the offset option is checked. These constraints should target the middle control bone. We then add copy location constraints to the deformation eye bones that target their corresponding control bone, making sure we use local space in the constraint. Finally, we add limit distance constraints to each of the 3 control bones that target their respective base bone. By doing this, we limit the distance that the eyes can move. So, now you can see that the bones cannot move more than the selected distance away from their respective base bone. With that done, we can now control the eyes intuitively. To complete our rig, we must duplicate the head and nose deformation bones and move them to the control layer, renaming them with the prefix CTRL. Now we have control bones for the head and nose, but they currently do nothing. We must return to the deformation layer, and for each of the deformation bones that we duplicated, we add a copy transform constraint that targets their respective control bone. After checking that all the parenting is correct, you can see that the control bones affect the deformation bones, and in turn, the grease pencil objects. Something to note, I noticed that the ears became unparented to their deformation bones. I fixed this by reassigning the vertices to their vertex groups. So that's this stage complete. We now have a fully rigged grease pencil head, ready for animation. In the next video, we will be expanding on this rig by creating a head turn using action constraints. Also, we'll be adding more mouth shapes to allow us to lip sync to audio. This will really bring our character to life, giving more flexibility when animating. Please feel free to ask any questions down in the comments, and I will do my best to answer them. Thanks for watching, and hopefully I'll see you around.